Inside your head, there's this incredibly delicate system, a constant life-giving river flowing through the most complex organ you own. But what happens when that river suddenly floods? Today we're talking about hydrocephalus, a condition where the brain is literally under pressure from its own protective fluid. And it all starts with what you could call a simple breakdown in the system.
To really get our heads around this, I want you to think about your brain's fluid system, kind of like the plumbing in a house. It's this beautifully engineered network of pipes and drains, and it's always working silently in the background. But when it breaks, well, the results can be absolutely catastrophic.
So, here's the official definition. Hydrocephalus, which literally means water on the brain, it's all about a backup. Way too much cerebrospinal fluid, or CSF, gets trapped, and that pressure starts to build and build. But to really understand the backup, we first have to understand how it's supposed to flow in the first place.
All right, so let's trace the path of this amazing internal river and see exactly how it's supposed to work when everything is going right. This fluid, CSF, it does so much. It's a shock absorber, a nutrient delivery service, and a waste removal system all rolled into one. It cushions your brain from getting banged around and keeps the whole environment perfectly balanced so your neurons can fire properly. It's pretty incredible stuff.
And the journey this fluid takes is just amazing. It starts deep inside the brain in these chambers called ventricles. Then it flows through this whole series of channels, completely bathing the entire brain and spinal cord, before it's finally absorbed back into your blood. It's a perfect, continuous loop.
And get this, your brain cooks up about 500 milliliters of this fluid every single day. That's more than a big can of soda. But at any given time, you only have about 150 milliliters in there, which means the system is completely recycling itself more than 3 times a day. That balance has to be absolutely perfect.
So, what happens when that perfect balance gets broken? Well, when the flow stops, the pressure starts to build, and inside the skull, the brain has nowhere to go. And this plumbing system, it can fail in 2 main ways.
It really just boils down to 2 types of problems. Over on the left, you've got what we're calling the clog, or non-communicating hydrocephalus. In this case, something is physically blocking the pipes inside the brain. Then on the right, you have the drain failure, or communicating hydrocephalus. Here, the pipes are totally clear, but the drain at the end of the system, where the fluid is supposed to be reabsorbed, that's what's broken.
The clog, the most common culprit, is something called aqueductal stenosis. It's basically a narrowing of a tiny but super critical channel. Or, a tumor could grow and just physically block the path of the fluid, creating the exact same kind of backup.
Now, for the drain failures, the problem is usually at the very end of that journey. Things like scar tissue from an infection like meningitis or blood from a hemorrhage, they can basically gum up the works. They clog up the specialized structures that act as the drains, and that prevents them from absorbing the CSF back into the bloodstream like they're supposed to.
Okay, so with all this pressure building up, the body starts sending out alarms. But here's the really interesting part. These alarms, the symptoms, they look completely different depending on how old the patient is.
So why the huge difference? I mean, it's the same problem, right? Well, it all comes down to one thing: the skull.
Think about it. In an infant, the skull bones haven't fused together yet, so they can actually expand to make room for all that extra fluid. That's why you see these physical signs, like a head that's growing way too fast or a bulging soft spot. But an adult skull? It's a rigid box. There's no give, so that pressure has nowhere to go but inward, squeezing the brain itself. And that's what causes those intense headaches, the vomiting, and the serious vision problems. There's also this specific type called normal pressure hydrocephalus, which you often see in the elderly, and it has this really memorable set of symptoms. Wacky refers to dementia-like cognitive decline. Wobbly is about a very distinct, unsteady way of walking, and wet refers to urinary incontinence. The tricky part is that it often gets mistaken for just getting old, which can make getting a correct diagnosis really difficult.
But now for the good news, okay? While this is a really serious condition, there are some incredible ways that neurosurgeons can step in and, quite literally, restore the balance by fixing the brain's plumbing.
First things first, though, you need a blueprint. I mean, you can't fix a plumbing problem if you don't know where the clog is, right? That's exactly where an MRI comes in. It gives doctors this crystal clear picture of the brain's ventricles and helps them pinpoint the exact cause of the fluid buildup.
For decades, the most common solution has been the VP shunt, and really it's an internal bypass pipe. A surgeon places this thin, flexible tube into one of the ventricles in the brain, and then they run it under the skin all the way down to the abdominal cavity. The excess fluid just drains there and gets harmlessly absorbed by the body. It's a truly amazing piece of bioengineering.
But shunts are not a perfect one-and-done fix. Just like any piece of plumbing, they can get blocked, or they can get infected. Sometimes they can even drain too much fluid, which causes a whole different set of problems. This means, for a lot of people, a shunt is a lifelong commitment that requires constant monitoring and sometimes even multiple revision surgeries over a lifetime.
So, because of those potential complications, surgeons developed an alternative for certain kinds of hydrocephalus, especially for those clogs we were talking about earlier. It's called an endoscopic third ventriculostomy, or ETV for short.
So instead of rerouting all the fluid with a long tube, the surgeon uses a tiny camera to go in and create a new drainage path internally. By making a small hole in the floor of one of the ventricles, the fluid can now flow right past the blockage. For the right patient, it is such an elegant solution that avoids having a permanent implant in your body.
So we've looked at the whole system, how it can fail and how we can fix it. But when you boil it all down, when you've got this immense pressure building inside the most important organ in your body, what is the single most important factor?
It's early detection. Simple as that. Whether it's a parent noticing their baby's head is growing a little too fast, or an adult who finally decides to get those persistent headaches checked out, recognizing the signs quickly is what truly makes all the difference in the world.
Because if it's left untreated, the consequences are severe. We're talking permanent brain damage, vision loss, and even something called brain herniation, where the brain tissue is literally pushed out of place. So understanding this hidden flood is really the first step to stopping it. It's just a powerful reminder of the very delicate and absolutely vital balance within.